Good evening, I'm Chris Chase, Product Manager for Slick Sleuth, and my colleague Glenn Roberts behind the camera. We're doing a quick demonstration of jet fuel detection using a Type 3 Slick Sleuth SS100, which is an optical, non-contact oil spill detection system for detection of spills on ground or more typically on water and moving water. We have more than one type of sensor. The SS300 has a 5-meter range. The SS100 in this explosion-proof package is rated for 1 meter, and is typically spec'd for applications within a small sump where it can be placed close to a waterway surface or in tank farms inside of tank dikes. I have a few types of fluids here that we're going to demonstrate the detection on water: jet fuel, or Jet A, aviation fuel, and diesel, marine diesel, which here in the United States and Mexico is dyed red. And we don't have a perfect setup, but we have a blinking red light here that will simulate or will indicate that a spill has occurred. So without too much ado, this is basically a UV fluorometer, so it's broadcasting in the ultraviolet wavelengths, and if hydrocarbons are present, they fluoresce at a slightly longer wavelength. That's how we indicate the presence of oil on the surface beneath the sensor. The optical beam is about a 10-degree spread, so it sees a somewhat finite area. So strategic placement of the sensor is key, often where the discharge from some location could take oil to an area where you didn't want it to be. So protecting against a spill occurring is the most typical application. These buckets have clean water in them. It can be moving water, flat calm water, or you can see a ground-like surface. And if the water is placed under the sensor, it does not alarm, and it thinks that this is the normal operating condition. I'm going to start with jet fuel. Excuse me for blocking the camera. Managed to get some fuel into the bucket, and there's just a couple drops there. The alarm starts blinking, and where the sensor connected to a PLC, it could automatically close a valve or turn off a pump capturing the water. It could divert the water to a containment area. It could activate a local audio-visual alarm, and it can send a signal back to a SCADA system or a whatever system is used for monitoring in the distributed control system, DCS, in the industrial environment. Oil can be moving around, and it still detects. If the oil goes away to a ground condition, the alarm stops. If we return clean water, for example, if a spill just passed by and it was an incidental event, and I don't know how well it'll be visible here, but I mean, there's hardly even a rainbow sheen on this water. It was literally like 2 drops of jet fuel. Again, jet fuel present. This setup, the sensor's taking a burst measurement every 5 seconds, sort of the typical default setup. We're at a fast-moving stream passing underneath the sensor. We have 2 Hertz sampling, or 2 flashes every second. Now you can hear it going did. It's 10 flashes once every 5 seconds. But for some applications where we put this on a buoy or some application where you don't need rapid sampling, then it could be set to 30 seconds, a minute, whatever period made the most sense for the application. If we go to our second product here, which is diesel fuel. Need a few drops of that. That was about 3 or 4 drops. Similar result. And it happens that these lighter oils or white oils do tend to make a sheen on the surface and the ability to detect in very slight amounts. We don't output a ppm or a concentration measurement because we don't typically know the volume of water, and it's a surface measurement. But to say that detect sheens and broken sheens and like drop level or micron level sensitivity is a fair statement. And then in many applications where a bit of a sheen is expected, we could set a baseline on this sensor using a magnetic wand, make this the normal background setting, add more oil, get a similar detection. So in essence, if we reset the baseline, it would do that. And when more okay, it would do that. So just as a quick example, and particularly for our channel partner and overseas agent KS Lowe at Oil Spill Science Solutions for airport applications and a shell oil application that he's interested in pursuing in Singapore. We'd like to support him, and this has been a demonstration of our technology. Thanks very much, and feel free to contact us.